Hello everyone, how's it going? So today we're going to do a little bit about text detection and text recognition. So we're going to combine both the text recognition and text detection into both. So if you haven't watched my past two videos, I'm trying to cover a project where we are trying to do a robust and a very strong text detection and recognition system. So the first video we covered was about text detection, where we used the yeast algorithm. If you haven't watched that video, I'll put the link in the description, but it's important for us to understand how those two programs were running, because we're going to be using the same principles and combining them in this project. So I'll put the link in the description if you need to watch that, but if you know how it's done, then it's fine. So the first step is to do the text detection, where we are using the yeast algorithm to identify where the bounding box for the text is. The second step is the text recognition, where you could, once you know where the text is, you could give it a Tesseract and it could identify the text written in it just like that. So Tesseract and yeast algorithm, they work very well in their own domains. Yeast for detecting the text in the wild, and text recognition by Tesseract. So these both are very good algorithm, but we want the power of both into one. And the way we are going to do is in this video. So I'll show you a quick demo of to see how it actually is running. And I have the program up here. We'll give it a few seconds. And this is the original image, and this is the detected and recognized text. So the green bounding box is nothing but the yeast algorithm, which is identifying where the text is, and the red color font which is written here is the output from the Tesseract. So you can see how the original image, which is here, and these are all colored images. These are very noisy images. You can see there are all types of different data in it, and even with that, these algorithms are working and performing well. So that's what we are trying to achieve here. And this is built up on both those programs. So I'll put the link in the description so you understand where I'm going to go through, because I had went over the text detection and also the Tesseract in the previous videos. So I'll put the link in the description so you can go back and see how we covered those two topics. Now these two items are for the text recognition. So OpenCV and Tesseract is what we are using for recognizing the text, and these guys are being used for the detection algorithm using the yeast system, the detection system which we used to identify where the bounding text is. Now this is the we covered in the first video. This is nothing but the neural network which the yeast algorithm had used in order to identify where the text is. So, and I've defined this function called the text detector, and this is nothing but if you provide the image, it would go ahead and process the image initially using the yeast algorithm, and then it will go through the recognition aspect. So I'll go over that in a few minutes, but before that I want to go over what's the main function of this program. So I have this 4 or 5 images loaded here, and I have provided them in an array so that I can read so that I can read and process them in a sequential fashion. So I have defined them in an array fashion here, image 0 1 2 3 4, and all of them are being read here and saved into these variables 0 1 2 3 4. And now I have this small function, or a line of code which is reading the image and then passing it to the text detection function up on the program. So I have this I in range 0 to 2, and the reason I'm doing that is so that I can loop over these set of images 2 times. So 0 to 2 is nothing but 0 and 1. It won't count 2, and it will allow me to run this particular loop 2 times. So what am I doing in this loop? I'm calling for img in array. So what it does is, so for every image which is in an array, it would allow me to run this particular set of line of codes. So what am I doing? The first step I'm doing is resizing this image into 640 and 320, because that's how I had defined my text detection, because each algorithm needs a multiple of 32, and hence I am using 640 by 320, and I'm resizing my original image, which is the img here, and saving it to the processed image img0, and interpolation by area. So OpenCV allows resizing by different methods, and this is nothing but allowing it to resize the through the area aspect, or the area property of the image. I'm again resizing it and saving it into this variable called original. The reason I'm doing that is because for you, I wanted to show how the original image looked like and how the processed image looked like, so you could identify the difference easily. And that's the reason I'm doing it 2 times here, just for the sake of this video, but it's not needed. And the text detected, this is the processed image which comes out of this function. So I'm passing the image 0 to this text detector, and this text detector is defined on the top. I'll go over that in a minute, but once we provide the image to the text detector, it identifies and gives out the information about the bounding box, and then gives us back the processed image. And we are simply using CV to IM show to show the original image and the detected image. I gave a time.sleep of 2 seconds, so that it gives us a few seconds on the screen to see and understand both the images, and nothing needed, but this is just for the sake of the video. And this is nothing but the wait key, and it is important for in order to put it on OpenCV. Without this, the IMShow function would not work. So it is important that we put the cv2.wait key function and break it well as soon as we press escape, or when we want to close the program, it comes back out of the loop and destroys all the windows. So that's all we are doing here in this loop. So now I'll go over what's this text detector. So before I go over there, I want to make you go through the process. So this is text detection in the wild, where you're providing the email the program with a very noisy and pixelated image. So you can see how pixelated these images are, and how much of noise is there in all these images. So it's very difficult for computer vision to understand where the text is, or for the text recognition algorithm to find out where the text is. So to help the text recognition system, which is the Tesseract system, we need to first identify where the text is in this image. So once we know where the text is, we can easily give it to the Tesseract, and then it can read the text for us. So the first step, as I said, is to identify the bounding box of where the text is, and then process that image a little bit so that Tesseract can do it very well. Because again, say for example, if these images, if you think about this, the bounding box would be somewhere like this, but you will notice that it's covering the blue color background, the white color background, the gray color background behind the text. If it was plain, then Tesseract would have been very easy to identify, but in this case there's so much of noise behind the text, so it won't be very easy to do an accurate detection. And for that purpose, we're going to be processing the image a little bit. We're going to be changing the image to a grayscale, so that there's not much of information about the color, and we can reduce the noise before we pass it to Tesseract. So I'll go into the text detection function right now, and as we discussed, we are providing the image which we want to process to this function, and I've defined it by def text detector. So this is the original image. I went over this whole loop in the original video. I can go over this again, but the video would be too long for unnecessary reasons. Now you can always go to that image, and I'll be uploading this program on GitHub so you can use it from there as well. But all this step is nothing but the text detection system which the yeast algorithm was using in the previous video, and I'm just using that all the way going till here. So until here, until we identify the boxes, until we identify the bounding box of where the text is, I'm using the same function, same code which I used in the previous video. And from here is when is where I did the processing for Tesseract. So what I'm doing here is, once I know where the boxes are, where the important boxes are, I am defining the text by giving here. So I define where the text is, I define where the bounding text is by giving the ROI of the image. So ORIG here in this case is nothing but the image which we had provided, and I'm creating a bounding box or a ROI, which is region of interest. So from the whole image, I'm only going to be using that bounding box where the text is supposedly present, and I do that by providing the y coordinate and the end y coordinate. So I provide the y coordinates of both the first box and the second box, and I provide the x coordinates of both the starting box and the ending box. And if you notice here, I'm using this boundary. The reason I'm providing this boundary is just to give some sort of cushion on the bounding box, because I'm noticing that the yeast algorithm, sometimes it takes a very small box, it identifies the text, but it doesn't give the whole box, because if it's not fully detected, if the text is not fully captured, then Tesseract cannot work properly. So I'm giving this boundary so that we can give some sort of cushion or boundary to the box, so that when we give it to Tesseract, it has a little bit information about the background, because that's how Tesseract was trained. Tesseract was trained so that it understands where there is a little bit of background, and then on top of that the text is present. So we want to provide a little bit of background, otherwise Tesseract will not work properly. So I provided a boundary of 2. You can provide 5, 10, whatever works for you, but I've noticed that 2 was working fine for the images which I had, and it's something which will work on trial and error. So I'm providing the start y and end y because the rectangle box is defined by these 4 coordinates. So if you think about a rectangle, the top left corner of the rectangle is defined by start x and start y, and the bottom right corner of the rectangle is defined by end x and end y. So I wanted to provide the bounding box for the image, and the way we do that is by using the y coordinate of the starting of the top left corner of the box and the y coordinate of the bottom right corner of the rectangle. And similarly, we also want to provide the x coordinate of the starting, which is the top left corner of the rectangle box, and end x, which is the x coordinate of the bottom right corner of the rectangle box. And we're giving some boundary just to provide some sort of cushion. So the plus boundary, so that if you understand, it's nothing but giving a boundary box for the rectangle so that I can expand the rectangle a little bit. The second step is converting that particular bounding box. So this is, the text is nothing, it's don't get confused by the word text. It's not a string, but it's an image, and it's an ROI image. So it's just a small portion of that image where the text is present, and this is the region where the text is present, and I am converting that into a gray image. So I'm converting it from a BGR to a gray value so that we can remove those noise which is coming up because of color profile behind the text. So we want to change that and move it from BGR to gray, and once we're done with that, we save it back into the same region, and this is where we pass it to Tesseract. So after this step, after we convert it into gray, the image is fairly visible, and it's very good to provide, and it's at a stage where we can now call the Tesseract function and help recognize what the text is. So we're going to be using the PyTesseract dot image to string and provide the region where the image is present, which is the text, and the text recognized, only if I knew the correct spelling of recognized. So text recognized is storing the string, which is, it's now no longer an image, now it's a string, and it's stored here. And now I'm going to be using the CV rectangle function to draw the bounding box on the text, and do that by if you have noticed the processed images, the demo, the green color boxes is what this rectangle is going to draw. So I'm providing where I want to draw. I want to draw it on the original image, and I also want to use the same starting x, starting y, and ending x and ending y coordinates, which we have it from here, because that's where we know where the boxes are. And the 0, 255, 0 is nothing but the color, which is green color, and 3 is the thickness of that box. The second step is to put the text which we detected here, and we're again going to be using the same original image and use the text that was recognized in this step and pass it here so it knows what it's putting it on the image. And where do I want to put it? I wanted to put it on the index and y. This is nothing but just specifying where, and where do you want to put that text on the image. So we are providing the coordinates of the image, and this is the font which we are providing. So OpenCV has a set of fonts, and this is one of the fonts that we are using, so that in order for OpenCV to write the text on the image. The 00255 is nothing but the color, and 2 is the thickness of the text, and 00255 is nothing but the red color. And CV2 line A is the type of line which we are going to be using to write the text. Once we processed everything, we want to return back the original image which was processed here. It's no longer original, it's processed. I should have used a different variable for it, but it gives the picture that we have processed, we have put the image, we have put the rectangle, and we are ready to give it back to the function. So return original is going to come back here and give it back to and save it into the text detected. So now we are ready with the recognition, and we are ready to show it off. So if you want, I can quickly go over again the demo just so we know how it is coming up. So this is the original image, and this is the processed image, and you can see how it's working out fairly well. There is some noise here, there's some noise as well here. You can see stop T, subscribe, like, comment, definitely yes, and self isolate. So this is for working out fairly well for such a noisy picture. So for now it's good, and in the next video we'll see how we can pair these algorithms with Alexa, with Amazon Alexa, so that we can make Alexa read the text for us. Wow, Alexa got invoked right now. But the next step would be where we will provide this system to Alexa so that Alexa can read it for us. With that, we come to the end of this video, and till then, stay safe and have a good day. Bye-bye.